Hey guys, this is Arvind and you're watching Learn with Arvind. In this video, we'll be discussing on Parseval's formula. Parseval's formula is given by integral minus L to plus L f of x a whole square dx is equal to L times 1 by 2 a naught square plus summation n is equal to 1 to infinity a n square plus b n square. Now we will be proving this. Its proof is given by, we know that the Fourier series f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity n cos nx n cos n pi x by L plus bn sin n pi x by L. Let's mark this as equation 1. Now multiply equation 1 by f of x on both sides and we will be getting f of x a whole square is equal to a naught by 2 times f of x plus summation n is equal to 1 to infinity a n f of x times cos n pi x by L plus summation n is equal to 1 to infinity bn f of x times sin n pi x by L. Now integrating both sides by the limit minus L to plus L, we will be getting f of x a whole square. Integral minus L to plus L f of x a whole square dx is equal to a naught by 2 integral minus L to plus L f of x dx plus summation n is equal to 1 to infinity a n times integral minus L to plus L f of x cos n pi x by L dx plus summation n is equal to 1 to infinity bn integral minus L to plus L f of x sin n pi x by L dx. Since we know that integral minus L to plus L f of x dx, it's a 1 by L times integral minus L to plus L f of x dx gives us a naught. So integral minus L to plus L f of x dx is equal to L times a naught. Here we are having integral minus L to plus L f of x dx. Here we will be substituting L times a naught. Similarly, integral minus L to plus L f of x cos n pi x by L dx is equal to L times a n. And integral minus L to plus L f of x sin n pi x divided by L into dx is equal to L times bn. Now we will be substituting these values, which is given by minus L to plus L f of x a whole square dx is equal to L times a naught square plus summation n is equal to 1 to infinity a n square L plus summation n is equal to 1 to infinity b n square L. Now taking L as common, you will be getting integral minus L to plus L f of x a whole square dx is equal to L of a naught square by 2 plus summation n is equal to 1 to infinity a n square plus b n square. This is given by Parseval's formula, in which we will be proving sums which consist of sum of numbers which would be a series, and we will be relating that to another number. A Parseval formula is given by, in the case of full range Fourier series, Parseval formula is integral minus L to plus L f of x a whole square dx is equal to L times a naught square by 2 plus summation n is equal to 1 to infinity a n square plus b n square. For half range Fourier series, that's for half range sine series, it's given by integral 0 to L f of x a whole square dx equal to L by 2 times a naught square by 2 plus summation n is equal to 1 to infinity a n square. Now half range sine series is given by integral 0 to L f of x a whole square dx is equal to L by 2 summation n is equal to 1 to infinity b n square. Now by using the sine series for f of x is equal to n in the range of 0 to pi, which is a half range series, we will be showing this, that we will be proving this thing. Okay, now half range sine series is given by f of x is equal to summation n is equal to 1 to infinity bn sin n x. Now we will be finding the constant bn. Bn is equal to 2 by pi integral 0 to pi f of x sin nx dx. I will be substituting the value of f of x, which is 1. Now we will be integrating sin nx. We know that integral of sin nx is dx is equal to minus cos nx divided by n. Now applying the limit, we will be getting 2 by pi taking n as common and minus as common, cos n pi minus cos 0. Since we know that cos n pi is equal to minus 1 power n, and it is equal to minus 1 when n is odd and plus 1 when n is even. If n is even, then it is given by minus 2 by n pi 1 minus cos 0 is equal to 1. So it is 0 when n is even, and if n is odd, then it is given by minus 2 by n pi minus 1 into minus 1 minus 1, which is minus 2. Minus 2 times minus 2 is 4, so bn is equal to 4 by n pi. Substituting this value, you will be getting f of x is equal to summation n is equal to 1 to infinity 4 by n pi times sine nx. Now substituting the value of f of x and putting values for n, we will be getting 4 by pi sin x plus 4 by 3 pi sin 3 pi plus and so on. Here n is not even. When n is even, it would become 0. Therefore, we will be left only with odd terms. Now using Parseval formula, we will be getting integral 0 to L f of x a whole square dx is equal to L by 2 into v1 square plus v2 square and so on. Now substituting the values, getting integral 0 to pi 1 dx is equal to pi by 2 times. Now v1 is given by 4 by pi the whole square plus 4 by 3 pi the whole square plus 4 by 5 pi the whole square plus and so on. Now integrating 1, we will be getting x pi by 2 and we will be taking 4 square by pi square as common, which is 16 by pi square, and we will be writing the leftovers, that's 1 plus 1 by 3 square plus 1 by 1 5 square plus and so on. Now cancelling out 2 1 16 and pi square, we will be left with, now we are applying the limits, so it's pi is equal to 8 by pi times the sum of the numbers. Now cross multiplying pi and take cross multiplying 8, we will be left with this answer. Now we proved the result, hence proved. Thank you and see you in the next video, guys.